Hello, this is Dr. James Camp of Lee College in Baytown, Texas, and this is my presentation on working with variables in C++. A lot of what we talk about here will apply to any other C family language as well, C#, Java, Standard C. They all use about the same syntax with variables. So what is a variable? A variable is a named memory location. So if you picture the memory of a computer as being a series of boxes, okay, we might store different things in these different boxes. The first box might store the number 1, 2, 3. The next box might store the number 4, 5, 6. The next one might store an approximation of pi, 3.1415. And the next one might store the letter A. Okay, that's a lowercase a, which would be different to a computer than an uppercase a. So each of these memory locations wants to be, contains a different value and wants to be referred to in a different way. And the way we refer to them is with variable names. So this one might be named ABC, and this one might be named DEF. This one might be named pi, with a capital P and a capital I to remind us that it's a very important number. And this one might just be called my letter, to indicate that my favorite letter is A. I don't know. It's not sure that that's actually my favorite letter, but there we go. So you can see that I've given each of these memory locations a name. That name is called a variable because I can change, I can write a statement that says ABC equals 7, 8, 9, and suddenly the computer is going to rewrite this variable, or rewrite that memory location to hold the value 7, 8, 9. So that's why we call it a variable. It can vary from time to time. I could write a statement that says my letter equals Z, and suddenly the computer is going to rewrite that variable to hold the letter Z. Okay, so that's how variables are called variables. Why do I call them named memory locations? Well, each variable has a place in memory that holds its value, and each value is assigned a name. It would be very inconvenient to program a computer if we had to remember the exact memory address of every single one of these boxes. Address 012 holds 789, but address 013 holds 456 or something like that. We'd get very confused about which memory address was which. So we can give them memorable names that's a lot easier to work with. There are some rules for these names. They have to start with a letter. Okay, so you can't have the name 123 as a variable name. It can be a value that you assign to a variable, but it can't be the name of the variable. If you wanted to have that, So the name 123 will not work, but the name A12 works perfectly fine. They have to contain only letters, digits, and we're allowed to use the underscore character. Okay, so we couldn't give a variable the name ABC123 because this space here is not allowed. But if we wanted to have that same idea, we could go ABC underscore 123, and it looks to the casual reader as if I've put a space in my name. Okay. Now that's kind of a silly name, but this allows you to come up with interesting, actual names, like if you wanted to have variables first name and last name in your program to keep track of a person's first and last name, you can do that using the underscore character to make it look like you've used two words. So you can't have any white space in your names except for that underscore character. And then this isn't a rule, but it's what's called a convention. They typically start lowercase and use use uppercase to start new words. Okay, so by this rule, having a computer that, having a variable that was called first name would be discouraged because that capital F has meanings in some dialects of C++. So you would usually make your variable first name. And or, again, as we had shown just earlier, you could use the underscore character to represent a new word instead of using an uppercase. Using uppercase letters to start a new word is called camel case because it looks like the capital letters are humps on a camel. Using underscores is called snake case because it looks like you have a long snake sort of slithering across your program. Okay, so those are the basic rules for naming memory locations. The other thing you need to know about variables is that they have defined types. Just as you might imagine that in a parking garage, you have spaces for car, and then a couple of thin spaces that might be for a bicycle. Okay, they have room for a bike, but not room for a car. And you might have a very long, wide one that's room for a handicapped van so that there's room to load a wheelchair into it or something. Similarly, when we define our memory boxes and assign values to them, each one has a different type to it. This one might be type int, meaning an integer. This one might be type short, meaning a short integer. This one might be type float, and this one might be type char, meaning character or a letter. So for these, I could assign the values 1, 2, 3, 4, 5, 6 for an integer, but only a smaller number like 789 for a short. Float, here's where I can hold my 3.14159 for pi. And a character would only hold a single character, like going back to my letter A from earlier. Okay, those are what we call basic types in C++. You can have more complicated types, like a string that holds a series of characters, or an array that holds a series of integers, or there are all sorts of other types that C++ is capable of representing. See my presentation somewhere else on my YouTube channel for the differences between the types of numerical values. Okay, so now that we understand the idea of integers and floats, of variables and their types, let's talk about how you declare variables and assign them values. In the C family languages, you declare a variable by first naming the type. So we might want to declare an integer, so we'd say int. Then you give it a name. My int. My integer, we'll say. A general rule for assigning variable names is that people used to assign the shortest variable names possible because they didn't like typing. But most computer programming environments these days have word completion routines built in, so you can assign fairly long variable names and have them automatically completed every time you try to type them. So longer names actually make your program easier to read, because you don't have to try to figure out what I meant when I said my int. You can say my integer. Oh, of course, he meant an integer. So my integer could be just left like this, end the line with a semicolon, because we always end lines in C++ with a semicolon. This allows you to, you have now created a memory box, given it type int, and given it the name my integer, but you haven't assigned any value to it. Notice that this box is still empty. In some C family languages, like Java and C#, this would be auto-initialized to a value like 0, just to make sure that there's something in that box. In standard C and in most versions of C, most implementations of C++, this value actually holds whatever the current contents of memory were left over from the last program that used that memory box. So maybe it reads 1, 2, 4, 6, 7, 9. Okay, is that the value you want there? Probably not. If you then go to use this variable someplace, if you call cout my integer, different programming languages will do different things. The standard C and C++ will just output that 1, 2, 4, 6, 7, 9 that was left in that memory location from whatever program used it last, and you will be left with a very confused user as to why that number is coming up. C# and Java will tend to give you an error message saying that this variable has not been initialized. So the better practice when declaring a variable is to say int my integer equals, and give it a starting value. Let's say 42. So my integer now, instead of holding whatever variable had been there, whatever value had been in memory before, now holds the value 42. Okay, this idea here of assigning a starting value to a variable as you declare it is called initializing. And it is a very good idea to, a very good habit to get into, to always initialize your variables as you declare them. You can declare multiple values on one line. So if we want to declare a couple of double type values, again, see my presentation on numerical types to understand what a double is. We can say double pi equals 3.14159, and then we put a comma and we declare another variable. Square root of 2 equals 1.414. And then if we're done, we put a semicolon at the end of the line. Note that this only works if all of the variables that you're declaring on this line are the same type. So you couldn't declare a double and then an int and then a character. You have to declare a whole series of doubles. But what this does is it creates one memory box with the type double and the name pi and the value 3.14159, and then it immediately creates another memory box right next door, also of type double. Remember, this only works if they're all the same type. Name, square root of 2, and value 1.414. Okay, so we've now saved a little space in our program and created two variables in one line. Sometimes that makes your program easier to remember. Sometimes it just makes it more compact, or easier to read. Sometimes it makes it more compact. Okay. We can also add one more keyword. We can use the word const. Okay. Const double coefficient of friction, so equals 0.21. Okay. What this is doing is it's creating a memory box of type double, name, coefficient of friction, and it's assigning it the value 0.21, but then it's putting a lock on that value. Okay, and that means that this value will not change. I am telling the program up front that this is a constant, and so I'm never going to change that value. And if I try to change that value later in the program, the compiler will throw up an error. Okay. The last thing we should know is that after you've defined a variable, let's say sometime later in the program, you want to change the name, you want to change the value, you can say my integer equals 34, and the program will find the box called, the memory box called my integer, and will change the value to 34. Okay. This is handy because you can reuse the same memory location for several different values. You have to be careful that you don't redeclare the variable. You wouldn't come down here and say int my integer equals -21. Okay, this will not work. That will throw up a compiler error saying that you are trying to redeclare a variable, or that variable has already been declared. Okay, because any line starting with a type is assumed to be a declaration. So when you use the variable the first time, yes, start it out with the word int. When you use it a second time, leave out the word int so that we know that you're reusing a variable and not declaring a new one. Okay. It would be pretty useless to have all these variables if you couldn't do cool stuff with them. So I want to talk about two things you can do with variables. One is that you can input and output with them, and the other is that you can do some mathematical manipulation with them. So if we take a variable that's already been declared as my int, okay, or let's say my favnum, okay, and we declared it as int my favnum, and we initialized it with the variable 7, the value 7. Okay, so we've got over here a memory box, type int, name my favnum, value 7. Okay, we can do some cool stuff with it using input and output. So let's say we wanted to output it to the console. We could say cout the output operator in C++ is 2 less than signs. We could put in a string value here that says my fav number is, and then we put another output operator, and we put the name of our variable, my fav num, and we put a semicolon. And the result of that is that somewhere in a console window, we get the output string my fav number is 7. Okay. Great. We might want to tell the computer that we're ending the line there using the keyword endl, end line. Remember, C++ was written in a time when keystrokes were very, very valuable. We didn't have autocomplete built into our text editors, so instead of writing end line, people just wrote the 4-letter abbreviation endl. Okay. Same for console out getting shortened to cout. We could try to read in a new number. Okay. So we have to declare the variable before we use it. Int your number. And this time we cannot initialize it because we're about to read in a value for it. So we'll say cn, then the input operator is 2 greater than signs, making it look like the information is flowing in the other direction. Cn inputs to your num. So what this would look like on our little console window is we'd have a blinking cursor. I didn't tell the person that they were supposed to type a number. That's bad programming practice. What I should do is come in here and say cout what is yours, okay, and now our console will read what is yours, and then there will be a blinking cursor for me to write a number. Let's say the user here writes the number 3 and then hits a return key. So then the memory box your num would get the value 3, because 3 would come from console input to the variable your num. Okay, so that's how we can do input and output with variables. There are other styles of input and output. In standard C, we use printf and scanf functions, and I'm not going to take the time to define those right now, but the F stands for formatted, so it looks for a particular formatting in the input or output. In Java, you use system.out.print, and then you fill in between the parentheses what it is exactly that you want to print. In C#, you would use console.write, and again you would fill in between the parentheses what it is that you want to write. The C++ output is a lot more user-friendly for just easily constructing output statements, but there are definitely advantages and disadvantages to all 4 of these languages. Okay. And the last thing I want to talk about real quick is the basic mathematical manipulation of these variables. So let's say we define float math value equals 10.02. Okay, now we've got a memory location which has been designated as type float, has been given the name math value, and has been given the initial value 10.02. Okay. What happens next? Well, we can do some math. We can type math value equals math value divided by 2. Okay, well, that's going to take the value that's currently in math value, 10.02. It's going to divide it by 2, and it's going to store the output in math value. So it's going to overwrite 10.02 with 5.01. Now, all of the C family languages have a shortcut for this. If you're using the same value, you could type if you're using the same variable for input and output, you could type math value divide equal 2. And it will take math value, divide it by 2, and then set it equal to the answer. There are similar operators for plus equal, minus equal, divide equal, times equal, and if you're working with integers, there's even a percent equal, which takes the remainder of the division operation. Okay, we'll talk more about math in C in another video. There's even a special set of variables called increment and decrement operators, where you could say math value plus plus, and that's going to add 1. So we take the 5 and replace it with a 6. Okay, so that's what you might call a shortcut operator. It allows you to do a whole mathematical operation with just a single plus plus sign. And there is similarly a minus minus that lets you take away 1 unit at a time. Okay. What if we wanted to work with a new variable instead? We can say float new value equals math value minus 1.01. Okay, and that's going to take my current value, 6.01, subtract 1.01, and get 5.00. And it's going to store it because we've used a float keyword to declare a new value. We're going to create a new memory location here. Type float, name, new value, and we're going to stick in the result of our operation, 5.00. Okay? So those are some different ways you can manipulate variables. You can also mix and match these things. You don't have to declare a new value. We can now say new value equals math value minus new value over 2. Make a complicated equation here, and this whole thing will be evaluated and stored in new value. So math value is currently 6.01. New value over 2 would be 2.50. And so if we subtract this, we get 3.51. And now we'll stick that result in new value, because that's where we told the computer to stick the new value. So you can do all sorts of manipulations with variables once you have them. Store values, reuse values, manipulate values, all sorts of things. Okay. In my next value, I'll talk about math in C++ in more detail and show you how some of these operators work and how some of the other non-operator functions can be called in C++. In closing, I want to mention a couple of best practices for using variables and constants. And the thing I want to highlight today is the idea of documenting your code. Okay, this means making it so that if another programmer picks up your code, or if you pick up your code after a year has gone by and you're trying to modify a program you wrote earlier, you want it to be readable and you want people to understand what's going on. If I put in a line, weight 2 equals weight 1 divided by 2.2, you would have no idea what was going on with this. One solution is to add something called a comment. If I put 2 slashes, the compiler ignores everything after that point in the line. And so I can write a comment to a reader that says converts pounds to kilograms. That's still not the best code possible, however, because we've got what's called a magic, what programmers call a magic number. That is a number that's just been dropped in there with no explanation. A better way to do this is to use C++'s constant capability. So I can put const double pounds per kilogram equals 2.2 pounds per kilogram equals 2.2. This is a lot easier to read. Now, there's a convention in C++, it's not an absolute rule, but it's a convention that when you give a constant a name, you put the name in all caps to signify that that's an important value and that it's never going to change. We can go a step further here and now rewrite our code from earlier using meaningful names. Weight kilograms equals weight pounds divided by pounds per kilogram. Okay, this comes close to being what programmers call self-documenting code. That is, it is easy to read that weight in kilograms is weight in pounds divided by pounds per kilogram, so we're doing a unit conversion here. Okay, this is pretty easy code to read. You can pick this up after you've been gone for a while and say, okay, that's what I was thinking when I wrote that line of code. To be even clearer, however, we can use an introductory comment. And to use an introductory comment, you use an older style comment that starts with a slash asterisk, and then continues for as many lines of code as you want until you put an asterisk slash, or star slash as it's pronounced. So everything between the slash star and the star slash is ignored by the compiler. So you can then write this, the following code takes a user's weight in pounds and converts it to kilograms for metric calculations, such as, for example, a BMI calculation, which is done in kilograms and meters, or a whole variety of engineering calculations that these days have standardized on the metric system. Okay. So those are some good practices to get in, using meaningful variable names like weight in kilograms and weight in pounds instead of weight 2 and weight 1. Okay, you're not actually changing weight, you're just doing a unit conversion, so using the units in the variable names is useful. And replacing this bad old magic number with a much better self-documenting constant. Okay, from here we're going to get into programming in doing advanced math in C++, and then we'll get into decisions and loops.